another video. In today's video, we'll be answering the classified on Chapter 1, the particulate nature of matter. So let's get started. Question 1. Diagrams 1, 2, and 3 represent the three states of matter. For which states can diffusion be demonstrated by using simple laboratory apparatus? So we need to identify each of these. The first one represents solid matter, the second one represents liquid matter state, and the third one represents gaseous state. Diffusion can be demonstrated in both liquid and gas. So you can diffuse gas into liquid, and you can diffuse solid in liquid, and you can diffuse gas in gas. So the answer is C, 2 and 3. Heating a liquid causes it to become a vapor. What happens to the molecules of the liquid during this process? When a liquid turns into a vapor, it turns into a gas. So the molecules, do they become bigger? Nope. The molecule size stays the exact same because that depends on the atoms and the element itself. So it's either C or D. The molecules move further apart. Yep, that's correct, because it's turning from liquid to gas and the intermolecular forces are getting weaker, so the molecules are moving way further apart. So the answer is C. Question 3. Some sugar is dissolved in water. Which diagram shows how the particles are arranged in the solution? And we have the sugar particles represented by a gray circle, while the water particles are the white circles. In A, we see some sugar particles floating up while others are down, so they are just randomly distributed. B, we can see the sugar particles in between the water particles, with the water particles in amount over the sugar particles, because the water is the solvent. In C, we can see the sugar particles precipitating down there, and in D, they are floating up there. So the correct answer is B, because they are in between the solvent molecules, in between the water particles. Number 4, a solid metal is heated until it turns to vapor. The graph shows the temperature of the metal during this process. Which part of the graph shows the melting of the metal? Okay, so we have here point A. Just let me get to the whiteboard real quick. Right. Point A represents the nature state of the metal at room temperature, all the way up to 500 degrees Celsius. It's a metal and we are melting it, meaning that it's normally in the solid state. Right? At 500 degrees Celsius, it starts to change in phase. So B represents solid becoming a liquid, so that's the melting phase. Okay. C is when the temperature keeps rising from 500 all the way to 2200, and in that phase any part of the metal that hasn't already turned into a liquid starts liquefying until all of the metal is in its liquid form. D is at 2200, that's the boiling point, when the liquid form of the metal starts turning into a gaseous form. Okay. Which part of the graph shows the melting the metal? The melting, it wants the point at which the metal starts turning from its solid phase into the liquid phase. So that starts at 500, so the answer is B. Alright, because at C, that's the rest of the metal turning into a liquid. It just needs the starting or the melting point, the starting of the melting. So that's B. Number 5. Some students are asked to describe the differences between gases and liquids. 3 of their suggestions are: gas molecules are further apart. Okay, that's correct. Gas molecules are smaller. Nope, not necessarily. It depends on the element. Liquid molecules vibrate around fixed positions. Nope, not liquid molecules. Liquid molecules move past each other. Solid molecules are the ones that vibrate around fixed positions. So the suggestion that's correct is A. Gas molecules are further apart. Question number 6. A colored liquid vaporizes easily at room temperature. Some of the liquid is placed at the bottom of a selected gas jar. Which diagram shows the appearance of the jar after several hours? So we have a liquid that turns into vapor at room temperature. Okay. So if we leave that liquid for a few hours, all of that liquid is gonna turn into a gas. Okay. And gases diffuse, they don't just sit there, no, they move all around. So the gas will start filling all of the air in the jar, right? And we have a colorized vapor, so all of the jar will be colorized due to the diffusion of the particles of the gas. So the answer is D. 7. The melting points and boiling points of 4 substances are shown. Which substance is liquid at 100 degrees Celsius? Alright, we need to be smart while dealing with this question. Option A has a melting point of minus 203 and a boiling point of minus 70. Okay, so both of these are below 100. So if it's starting to boil at minus 70 and starting to turn from liquid to gas at minus 70, so at 100 it will definitely be in its gaseous form, because 100 is way over minus 70, so it will definitely be in its gaseous form. So option A is wrong. Alright. Option B is the same idea, minus 25 and 50. The boiling point 50 is still below 100, so we're not going to consider that one. We have either C or D. In C, we have a melting point of 11 and a boiling point of 181. So if we quickly draw a graph, here we have 11 and here we have 181. So it's just gonna be like that, solid, and then starts melting and then starts turning into the gas, boiling. 100 degrees Celsius is right here, below the boiling point, below 181. Okay, so in this point, the metal will be in its liquid form. Okay, because it's still below 181, it's below the boiling point. So the answer will be C. Okay. Question number 8. At room temperature, in which substance are the particles furthest apart? Furthest apart, so we are looking for a gas. So we have H2, we have H2O, we have magnesium, and we have magnesium oxide. So hydrogen is a gas. H2O can be a steam, or it can be just liquid water. How can we differentiate? It says at room temperature. At room temperature at 25 degrees Celsius, water is in its liquid form, of course. If you want it to be steam, you have to heat it to 100 degrees Celsius. Magnesium is a solid. Magnesium oxide is a solid that we'll talk about later on. It's a white powder, so it's a solid. So the answer is hydrogen. A. Question number 9. When there is no wind, the scent of flowers can be detected more easily on a warm evening than on a cold evening. This is because the molecules of the scent, we have gap 1 and gap 2, then in colder conditions. Which words correctly complete gaps 1 and 2? For gap 1, does the molecules of the scent condense? We know condensation is when we turn gas, into liquid. That is condensation. Is that what we're doing with the scent of flowers? No, that has nothing to do with the scent of flowers. So the scent of flowers is diffusing, right? If it's diffusing, the source of that scent is the flower itself. If it's diffusing into the air, so it's definitely getting further and further away from the flower. So is it diffusing nearer to the flowers? No, it's diffusing further from the flowers, and that's why you can detect the scent from further areas. So the answer is D. Okay. As for question number 10, a yellow precipitate is formed in the experiment shown. Alright. We have a flat dish containing distilled water. We have 5 drops of aqueous lead to nitrate on one side of the dish. Let me just take a quick screenshot so that I can annotate. We have 5 drops of aqueous potassium iodide, that's Ki, and that doesn't really matter right now. And we have 5 drops of aqueous lead to nitrate, that's Pb, NO3, all 2, and that doesn't matter either. Yellow precipitate forms after a few minutes. Okay, how did that precipitate form? Simply the precipitate formed here, which means that this one, the aqueous lead to nitrate, had to go all the way over here, and the potassium iodide had to go all the way here as well. They reacted with each other, but for molecules to react together, they have to hit each other, they have to collide. So they diffused, collided, and then reacted, forming the yellow precipitate. So the answer is C. Okay.